Got him. Good afternoon, everyone, and welcome for our first 30 days of ML talks. And we are glad to have here one of our speakers for today who would be teaching us Python and machine learning for beginners. So before I formally pass on the mic to Jude, I'm just going to have a quick introduction about him. He is a graduate of De La Salle University, a bachelor's degree in computer science and major in computer systems engineering. And he also graduated at Asian Institute of Management, carrying the degree of Master of Science in Data Science. Currently, he is a data engineer at AIA Film Life and also serve as an assistant professorial lecturer in computer science and data science at De La Salle University. So let's do welcome our first speaker for today, Jude. Hello, Jude. How
Hello,
are you?
good afternoon.
Thank you so
Hi.
much for agreeing to speak and share your knowledge to our attendees for today.
Thank you too for
Okay.
inviting me.
All right. Are we good to start, Jude?
Yeah, sure. I'm
All right.
good.
Okay.
Good.
I leave it to you.
Let's start. You can see the slides now, right? Okay. Yep. I think you can see it. Okay. Let's start. So, um, I won't dwell much on my background because I was already introduced. But yeah, I am currently a data engineer. But previously, I worked as a data scientist and AI consultant in ADB, and I'm currently an assistant professorial lecturer in DLSU, and I took data science and computer science um, back then. So, okay, what is the hype all about? Like, what's with machine learning? Why are we hearing it every now and then? So, who among you knows what this is? What AlphaGo is? Any ideas? Can I see the chat? Would it be possible to see that? Anyway, so AlphaGo is machine learning created by Google, wherein it was able to beat the top Go player. And if you don't know, Go is much more complicated than chess. So it is estimated that there are so many possibilities in this game that it exceeds the number of atoms in the universe. That's how complicated this thing is. And they were able to create an AI model that can beat the top player in this game. So this is really amazing. This is one of the things that we could do with artificial intelligence or ML. And I've also seen this paragraph on the internet, and I'll just read this for you. So, general artificial intelligence is going to happen a few years from now. There is now a reasonable amount of skepticism about whether AI will be an improvement on us. At present, its ability to generalize to new situations is questionable. The challenges of language processing and scientific modeling are significant, while ethical issues are formidable. However, it is clear that today's AI systems are progressing at an extremely fast pace and that their numerical capabilities are increasing. Would you agree with this statement that I got from the internet? Do you think general AI is going to happen a few years from now? Well, I'm not sure if I can see the chat. I can't, right? Anyway, actually, this paragraph is created by an AI model. So I just feed it with the first sentence, and the rest was generated by an AI. So this is also one of the things that you could do with AI. You could generate text, right? Pretty cool. So AI is very important nowadays, and we are at the forefront of Industry 4.0, wherein there are so many cool, high technologies. Like we have AI, blockchain, and other things. But I would like to introduce you first to the concept of industrial revolution, if you haven't heard of it. So, um, in an industrial revolution, there is a massive shift in how we live our lives. For example, back then we are mainly focusing on agriculture. Then we started to rely on factories. So that's the transition from industry zero, I guess, and to industry 1.0. And then you get the idea. So industry 1 to 2.0, we started to harness electricity, and then in 3.0 we started to use computers, and 4.0 is the synergy of all these systems. So everything's intelligent now. And now one of the main technology behind um, the advancements in industry 4.0 is AI. So what is AI? Well, generally speaking, when we try to mimic human behavior and apply it to our computer systems, that is AI. So even if it's a very simple task like um, probably classifying whether this image is a cat or a dog or any other very simple task. So well, actually, it's quite complicated with its image, but you get the idea. So anything that we humans can do, if we try to import that skill onto a computer, that's AI. Whether it's a very sophisticated one or an if-else rule, that's still AI. And one subfield under AI that is very hype nowadays is machine learning. So machine learning it is relies on data. So we feed the model with lots and lots of data, and um, the idea is it will be able to learn the pattern on its own without us it's um, manually coding the rules. So that's the beauty of machine learning. Whereas deep learning is just a subset of machine learning, specifically neural networks. So neural networks are loosely patterned after the human brain. It's not exactly how the human brain works, but that's the inspiration for it. And it is the um, core algorithm in many state of the art models that you will see nowadays, like image classification, object detection, any other advanced use cases of AI usually use deep learning techniques or neural networks. So to summarize, AI is the bigger umbrella, then inside it is machine learning, then inside it is deep learning. And there have been two AI winters already. So why is there an AI winter and what is an AI winter? So an AI winter happens when the expectations of society doesn't match what the research community can deliver. So because media will sometimes portray that we can already achieve this using AI, but in reality, we can't. And after some time, people will realize that we can only get here, at least for now. So that's where the winter happened. So it happened back then in 1970s and in 1980s because there was a mismatch in expectations. But recently, AI is booming because of lots of advancements, which we will discuss. So first of all, we have data. Um, and as I mentioned earlier, data is needed in machine learning models because what we're doing is we just feed it with lots and lots of data. And by doing that, it will um, figure out the pattern on its own. So because right now we have so many data, AI and ML is working. And not sure if you've heard of this phrase that the world's most valuable resource is data. Okay, let's proceed. So it is projected that we'll have 175 zettabytes of data by 2025, although this was conducted back in 2018 in this study. And what is a zettabyte? How big is that? So a zettabyte is 1 billion times 1 trillion. Very big number. And again, as we have more data, machine learning models will likely um, perform better than it was back then because you're feeding it more and more examples for it to learn from. So that's the first thing. We have data. Then second is hardware. This is the Moore's law. So the Moore's law states that the number of transistors on integrated circuit chips um, doubles approximately every 2 years, as you can see in this graph. So what does this mean for us? It means we have more computational power. In a single chip, it can perform so many calculations. And of course, since we're using computers here, we will benefit from that. More computations means faster machine, faster model. And lastly, there's the research. There's the algorithms. I mean, if you have hardware, if you have data, but you don't have algorithms, then what's the point? So this is one of the I would say this is one of the papers or research that started the hype in AI because back then people don't really believe that much in the power of AI, but after this paper, they're able to um, do the ImageNet problem, and they beat the second best performing model by a big margin. And this is the time wherein we're getting performance out of an AM model that is quite good, and this also used GPU. Back then, it's not that popular for us to use GPU, but this is one of the earlier researchers that use GPU. So yeah, and one of the um, authors here the is one of the godfather of AI, Geoffrey Hinton. So there are so many research just out there, but the point is, without them, we can't have the AI that we have right now. It's not just the AlexNet. There are so many more that is important in the field of AI. So these are the godfathers of AI: Jan LeCun, Geoffrey Hinton, and Joshua Benjo. So to summarize, um, the cost of the AI resurgence is data, hardware, and research. So some applications. So you'll better appreciate AI and ML. So um, face detection, right? It's one very popular use case of AI, and we can get very high accuracy with this. Although there are ways to fool these systems, but for the most part, they're good. And an improvement of this is object detection. So it's more complicated than face detection. So you have to um, detect the objects in a video, not just in an image. Oh yeah, I created this back then. So it's just this project that I have done using those things. So for example, because I like to do projects on AI. So yeah, it's object face detection, object detection, then some temperature scanner. So yeah, those are the things you could do with AI. You could also do self-driving cars, clustering, theme identification. You can do that with AI, plus NLP techniques. Text generation, right? So earlier I've shown you that paragraph. This is what I use to generate that. So for example, if you type something here, it will continue that. So you could do that with AI. Okay, so I will show you some projects about AI. Wait, can I share my screen for a bit? I'll open those. Wait, looking for it. And then give me a few seconds. Okay, here. So for example, this one. Let's try this one. I'll show you now. So this is Google's computer vision API. So if you like plug an image here, if you upload something, it will identify what that image is. For example, I do this. I upload an image of a cat. What will happen? It will identify that this is a cat, right? Very straightforward. What if we upload another picture? Dog. It was able to identify that there are two dogs here, right? Two dogs. What else? How about this one? Right. So it was able to identify the emotion of the person in that image, right? Mostly joy, then low for other emotions, objects, glasses, person, top, table. How about another example? So, how about a house? So, it was able to detect that this is a house, and yeah, the different objects in that image. Sorry. How about I upload my image? What will happen? So, mm, joy, a bit of joy, then low for the others. Objects, pants, person, top. Cool, right? So that's one of the things that you could do with AI. There's also this quick draw. So if you draw something, it will identify what that is. So let's draw a feather. I don't know,
I
feather,
see line. Oh, I know. It's feather.
feather. Skyline. I don't know. How do you draw a skyline? I'm not really sure. Let's just skip this. I think it's hard. I don't know.
I see line.
I, I want to skip this part. Hat.
I see pond. Or bread.
Hat.
Oh, I know. It's hat.
But you get the idea. I won't finish this part. So yeah, those are the things that you could do with AI. There's so many things you could generate music. You could do predictions for stock or whatever you want to predict. So yeah, so many applications of AI. So with that, let us um, proceed with the crash course on ML. So you better appreciate it. So how does ML work? Machine learning is the ability of computers to learn without being explicitly programmed. So we just feed lots of examples and it will learn. For example, I show you this picture. Picture of a, what is this? What do you think is this picture? It is a picture of a cat. So yeah, you can say that it is a cat. How about this one? Dog. This is a dog. Wait, can and then how about this one? This is I don't know a silhouette cat, maybe a cat. But how do we know that those images are linked to these concepts? Like this image, when we see it, I know that this is a cat, and this one, I know that this is a dog. Why do you think that's the case? It is because we have seen so many examples of these animals since we were born. So it's the same thing for machine learning systems. You feed a lot of examples. It's like a baby. It's dumb at first, but you need. But after giving so many examples, it will learn those things eventually. Okay. There are different types of ML. We have supervised, unsupervised, and reinforcement learning. For this crash course, we will be focusing on supervised because this is the easiest one to teach. Um, so supervised is when we have target and or label in our data set. I'll explain that later. I'll show more examples. Whereas in unsupervised, you don't have that. It's not labeled. So for example, in here, X is your features slash inputs and Y is your target output. We in machine learning, in supervised machine learning, it's going to try to figure out this one in between, whatever it is. The goal is to match the input to output with some transformation that we'll do in between. So, for example, um, this is my input and this is my output. What is this thing in between? The ML should figure that out for us. But this is an easy example, so we could actually figure out what this mathematical expression in between this. It's very simple. So it's just multiplication. 2.2. 2.2 times the input will become this. It's kilogram to pounds. Um, for this one, it's a bit harder than the earlier one, but you could still figure it out using few operations. So it's Celsius to Fahrenheit. So if you have this input, you apply this um, formula, you'll get this. And in machine learning, we don't have to figure out um, those things. We just use a model, and the idea is it will learn that mapping for us, the input to output mapping. If you have an input, whatever it is, you have an output, it will try to map that. So you could use lots of ML models for that. And you're not limited to the form that you were seeing earlier, just numbers. You could use an image because in reality they're all numbers. So if you feed an image, you use a model and then it will predict that it is a dog or cat or whatever is in that image. Um, you could also feed text data, feed it and then into some ML model and then it will return an output. So that's supervised machine learning. So in machine learning, uh, we if you wanna um, go in depth in machine learning, you will need skill in programming, statistics, probability, calculus, and linear algebra. But if you're just starting out, a bit of programming skill will do. But if you want to excel, you have to learn all these things. So there are different types of problems in supervised machine learning. There's classification and regression. In classification, our goal is to classify our data points. And for example, you have an maybe it's a problem wherein you have to identify the animals in an image. So, for example, this one cat, dog, horse, or bear. Or maybe you want to identify the um, sex of that person in the image or whatever data that we have. So it's male or female or pass or fail. So that is classification. Basically, you are picking one of the many labels that you have in that data. Whereas in regression, you are predicting numerical values. So an example of that's like click-through rate, stock price, or demand. Those are regression examples. So more examples. Regression, like for this one, you're trying to predict the temperature based on the cricket chirps per minute. So based on this visualization, you could easily see that there is a linear pattern. So if the cricket chirps per minute is high, then we expect the temperature to be high as well. You could also predict the power demand, this is the monthly demand visualization and hydro supply graph. For classification, again, we're trying to classify the data points in our data set. So this is like in this axis we have the sepal width and this is the sepal length, and you can see in this visualization that those data points that have low sepal length and sepal width are here. There are more or less this brown class that we have here. What is this color? Orange or brown? Something in between. So different models will have different ways of classifying your data. And this visualization is just to show you that yeah, they have different techniques of doing it. So use the appropriate model for the data that you have. So there are many models. Like there's naive Bayes, k-nearest neighbors, logistic regression, SVM, support vector machines, decision trees, and neural networks. Neural networks is deep learning once again. So just to give you an idea, so this is what k-nearest neighbor does. Um, y- when you're trying to identify the classification of your new data point, you just look at your neighbors, and that will be your classification. Very straightforward. For linear regression, you're trying to minimize the error. So eventually, this will become a line, at least for this data set. This line will um, have the minimum error in this particular data set. So if you have a problem that is uh, linear, then you might want to use linear logistic regression or SVM. If you're dealing with image data, use convolutional neural network. So yeah, basically, if you have there are different algorithms for different problems. That is the point. You don't use single algorithm for all the problems that you have. It's case to case. And if you need like a guide, then you can use the scikit-learn cheat sheet for using the models depending on the problem that you have. For example, in here, if you have more than 50 samples, go here. If you're predicting a category, go here. You have a label data here. If you have less than 100 key samples, use linear SVC. This could help you if you're starting. Okay, say we have already trained our model. What do we do now? We evaluate it. We have to know what is the performance of our model. And typically, we split it into train and test set. There are more better approaches for that. Like we have train val test, but for now, we'll just use train test because this is the simplest one. So um, you could split it in different ways, but most of the time we do 80-20 split. So 80% for train set, 20% for test set. And in train set, you could think of it as um, you could think of it as like studying for an exam. This is the set of data that we use to train the model. Whereas for the test set, that is the actual exam. That is the set of data we use to evaluate the model. So there are lots of evaluation metrics that we could use. Um, by default, when you use scikit-learn, we will do that in the hands-on session. By default, it uses accuracy for classification and R squared for regression tasks. But in many cases, especially for imbalanced data set, it is recommended to not use accuracy because this is very misleading. But I won't um, go in depth on that in this course because this is for just introducing you to the world of ML. But please take note of that. That having a high accuracy that doesn't mean that it's a good model. There are many times wherein it's not a good model. It's a accuracy will often fool you. So here are some pitfalls in evaluation. Um, Please take note of these. So we have overfitting and underfitting. So what are those? Overfitting is basically you memorizing the train set and performing poorly on the test set. And underfitting is unable to model the train set and generalize the test set. In this visualization here, you will see that on the left side, we have an underfitted model. It's just a line, but you can see it should be a curve. It should be a U-shaped model. But you used a line, so it's underfitting. The one in between is a good model. It's not perfect, but it was able to capture the trend, like this U shape here. On the right one, we have an overfitted model. It's like brute force. You are trying your best to capture all possible points, but in reality, that's not like the pattern. You don't have that sinusoidal parabolic wave function. So it's a U with some sinusoids in here. More examples of underfitting and overfitting. So if you have this data set, you just use the line to split it, and the one in between is the best one. It's like just okay. There are some misclassifications. Like in here, there's x two x's inside like this area that should be for the circle, but that's okay. And on the right one, we have an overfitted model. Right, this is too good to be true. So how do we typically do machine learning? Um, at a high level, we generally follow the scientific method. So what is the scientific method? We set the goal, we make a hypothesis, we collect the data, we test it, we analyze the results, we reach a conclusion, and we refine it, the hypothesis, and repeat depending on what we find. So, for example, as you can see here, the goal might be I want to predict how heavy the traffic will be on a given day. And my hypothesis is the weather forecast is an informative signal. Makes sense, right? Then we collect data, and then we train a model using that data. And then we analyze the results. Is this model better than the existing systems that we have? If not, um, maybe I should not use that model because of the many things that we have um, identified when we were doing the analysis. And then lastly is you could refine your hypothesis. Maybe we could focus on the time of the year, not the weather. Another important thing is framing your machine learning problem. Before you do all those models, you have to frame it properly. Like you have to, as you can see here, you have to articulate your problem, see if there's a data for that, design your data, you have to do the necessary pre-processing for the model that you'll be using, and so many more. So this is the typical pipeline when doing ML. You do the problem identification or framing, you construct or just get the data set if it's available already. You transform the data, you train the model, then you check the performance or the this is the evaluation part. So first thing, you have to identify the type of ML problem that you will be doing. You have seen this earlier already. So if you're picking one of n labels, that's classification. If you're predicting numerical values, that's regression. This one is an extra here. This is actually for unsupervised learning. So if you want to group similar examples, that's clustering. And here are some examples. Why is this important? Because you have to use appropriate model depending on the problem that you have. There are models for classification and regression and clustering. And please start with a simple model. You don't have to use complicated ones when you're just starting your model. Um, it's often good that you rely on tried and tested models because that is why they are popular and tried and tested because they work well. Even though if they're just simple, that's okay. At least you have a baseline. And usually the biggest gain in ML is the first launch. So yeah, just have a model running already. Don't spend too much time on optimizing it on using very sophisticated ones. The simplest ones will do at first. What else? We also do exploratory data analysis. This is really, really important because this gives us a sense on what data we are dealing with before we do the modeling, right? It's really helpful if you know what you are playing with. So perform some visualizations, do some statistics and whatnot, so that you better know your data. So here's an example on why we do EDA. This graph is called the unscom's quartet. So as you can see here, they are very different. Those four graphs are different, but the descriptive stats that it um, will give you are the same. If you try to like apply a linear model for this is what you will get. And if you check the descriptive stats, they're all the same. another example. So you can see different visualization, right? Very different data points, but they all have the same descriptive statistics. And that is why it is important that you perform EDA. Visualize your data first. See if it makes sense. You see, as you can see here, they have the same stats, but they're not the same thing. Oh yeah, I've already shown you this. So, um, tech stack. These are the libraries that we use when doing machine learning. So we have scikit-learn, NumPy, Keras, TensorFlow, PyTorch, Matplotlib, Pandas, Python. For now, we'll focus on scikit-learn in the hands-on session. For model training, this is the simplest code that you could use to run a model. Of course, if you're dealing with harder problem, you have to do more steps, but you could train and evaluate a model with these three lines. This is the simplest example. If you need more inspiration on your ML project, then you could look at Kaggle. There's so many projects there. There's also papers with code. If you need dataset, lots of datasets are in Kaggle. There's also one in World Bank and Google Dataset Search for tutorials. There's so many you could find on the internet. You just Google them. There's so many resources right now. Okay, I think we can proceed with the hands-on session right now. Are there questions? Okay, so I think it would be best if you do this together with me. I will send you the link. How do I send it? Anyway, so for those of you who are not familiar with Python and ML, this is how you import libraries in Python. And these three libraries are very important in the data science and ML space because um, they provide us the tools that we need to do pre-processing, table manipulations, and visualizations. We call them the data science library trio or trifecta. See them in almost all projects, in almost all code. So we just import them. Sorry, it's taking some time because I just started my session. Okay, but it should be fast. This one here is not really necessary, but I use this for aesthetics. You can ignore this part. I just want my graphs to be more pretty. Okay, so the dataset that we will be using for the session is the iris dataset. You've seen that earlier. So we have three classes here, 0, 1, and 2, and they correspond to Setosa, Versicolor, and Virginica. I have forgot to remove this part here, but this part is just for loading the data. Thing that you have to take note of. So I have X and Y, and X and Y contains X contains the input. So this is our input. So many, right? So I'm just gonna show a few of them for now, so it's easier to see. So that's the syntax for just showing the first 5 rows in our data. And Y is this. What this means is the first 5 rows in our data are all 0 or Setosa. Okay, next we perform EDA or exploratory data analysis. So we look at some descriptive stats for the different features that we have So we have four features. Um, Zero is sepal length, one is sepal width, two is petal length, three is petal width. That's I should have. Okay, I'll add the columns for you. Stats. So that it is easier for you to read. So there. Okay. And then we visualize our data. Um, this part might be a bit complicated for some of you who are not that familiar in Python, but the point is I'm just trying to visualize my data. I won't explain all the lines because it will take up most of our time, and I have so many to cover here. So this is what our data looks like. If we focus on the first two features, this is a scatter plot. So by looking at this, you could already see some clustering, some pattern. Like all the setosa flowers are here, all the virginica are in here, and all the versicolor are in here. There is some pattern already that you could see. So yeah, it's important to do some visualization. Let's also look at the distribution. So they have the same counts, which is good. Um, if you have a very imbalanced data set, that will be problematic for your machine learning model. If it's balanced, then we have no problems, like the ones in here. What else? Let's look at the distribution of the values for each um, class. Although this visualization here already captures that somehow, it, this is just a one-dimensional view of it. In the earlier one, we have two dimensions. So you can do the same for other um, features. So you can see that there's some, the setosa generally have lower values, versicolor have the highest values. For the sepal length feature, for the sepal width, though, um, versicolor has the highest. Virginica and setosa are almost the same. So there. Okay. Now let's proceed to the modeling part of it. We will be using sklearn library for the modeling. Um, so sklearn or scikit-learn is an open source machine learning library that supports supervised and unsupervised learning. It has tools for model fitting, preprocessing, selection, and evaluation, and many other stuff. This is very popular in the ML space, so we'll be using that. And again, to train and evaluate a model, we will only be needing these three lines. But of course, we will be adding others for pre-processing. So first pre-processing step that we will do. Oh, I have not imported it. Sorry, I have not run the earlier line. Because I commented it out. It's this one. Should have moved it here. So it's easier to see. So what does this line do? It splits the data into two. Remember, we have to have train and test sets. Train is for training your model, test set is for evaluating your model, the exam. So we plug in x and y. X is the input, y is the output. That size um, controls the size of the test set. So since it's zero point 0.2 or 20%, that means trains that will have 80%. And this random state here is just for reproducibility purposes, so that the output of this one will be consistent across all runs. So this line is just an extra. to make sure that everything's consistent. If you run that part, you'll have train and test sets. So there are four outputs here. You have xtrain, the input for the train set, xtest, the input for the test set, ytrain, the output for the train set, and ytest, the output for the test set. And if you look at the values, they're consistent. So initially we have 150 rows. If we split them, we have a train set size of 120 since it's 80% of the data, and 30 for the test set because it's 20% of the data. So I just did another graph here to show you what happens when we do the modeling later on. What is this graph for? Um, I want to show you that these are your train sets. All the ones that are colored, that's those are the points in your train set. And the black ones in here are in test set. So the model won't see them yet when you do the training. That's why they're blacked out in here. And later on, when we have done the training of the model, we will now predict those points. Our hope is that those classification for the black points here should match the one that we have earlier because this is the true classification. So if you do not include them, what will be their classification now? So they will be like the exam. And we study for these data points that we have here. Okay, so now let's do classification in sklearning. What did I press? So for now, we will be using the k-neighbors classifier model. So this is how we do it in Python. So just import it. And then we initialize the model. You could actually remove this. By default, it will have some parameters in there. But I just want to show you that these are some of the parameters that you could configure when sorry, when doing the initialization of your k-neighbors classifier model. So this is the initialization phase, the instantiation of the model, and then your second line is for training the model. In this one line, you're able to train a machine learning model. So we do that, and then we predict. So our first, this is actually, you can actually skip this part, but I just want to show you that if we feed it with these inputs, you'll get the following output. So for the first five inputs that we have these classifications. One is the Virginica, zero is the Setosa, two is the versicolor, and so on and so forth. Let's evaluate the model. So this is now your exam or your test set. The model hasn't seen this part yet. And if we check the performance of the model on the set that hasn't been seen yet, we got a perfect score. So it means we have a very good model. We also check the classification report. A very perfect score. If you want to see the other metrics, precision recall and form. Again, let's visualize our predictions. So this is the graph earlier, right? We have the black points here as the unlabeled ones. This is the test set. But after predicting their class based on the model that we have trained, you can see that I have colored them based on the classification that they have, and it's consistent with the ones that we have earlier. We have a very good model. Okay, what else? Let's do a spam classifier model. So I've already loaded the data for you. Um, this data set contains the subject of the emails that were sent to different users and the associated labels for those. So ham is for not spam and spam for spam. So this is the distribution in our data set. Um, we have lots of not spams or ham and um, a few, well, not that few, but almost half of the um, counts of the hams are spams. So I think this is already a good enough distribution. I won't perform other pre-processing except for the NLP part here. I won't explain that much the NLP part because it is out of scope of this course. Um, but first, we will be splitting the data. Right, that's the first step. So we have our train and test set. So we have thousands of rows, thousands of examples for the different sets. And now we will be doing the NLP pre-processing part, which I have not covered. But basically, I'm converting the text data that we have into a format that will be understood by computers because our machine learning models can only deal with numbers and we have text data. So how do we do that? Basically, we treat each word as like a feature. That's what I'm doing here. So now that it has been transformed into a format that can be understood by our models, we will be doing the modeling. So let's use logistic regression, another machine learning model. Same stuff. We instantiate the model. This is this part. And then we train the model. And then we check the score of the train set. So very high, of course, it's the train set. But what about the test set? We're still getting very high results, right? Near perfect. So to further break it down so that you believe that it's working as expected, I have identified the some of the rows that are hams and spam. So these are the not spam emails, and let's look at the text inside that. It's quite long, so I can show all of it. Though, uh, wait, if you really wanna see it, you can list. So this is the subject. All of these emails are not spam, and if we predict it using our model that we have trained earlier, you can see that it was able to predict it correctly. They are not really spam. How about the spam examples? Oh no, I pressed something. Anyway, this one. Yeah, this one, spam. So these are the spam emails, and yeah, when these are modeled, it was able to classify them correctly that they're all spam. So yeah, that is um, the basics of ML. I won't go to the regression here because I think we're out of time. It's already two, but it should be the same thing. It's the same process. You um, initialize the model, you train it, you evaluate it. Basically, this point with these three lines, you can now train and evaluate your model. Any questions? Okay, there's a question. What does labeled data mean? It means that um, in your data set, it has a label, it has a target, it has that column that says this particular row is this class. So someone must have um, manually labeled them beforehand. So, for example, this one here, this is a labeled data. If we have this input, this should be the output. If we have this should be the output. Ham. If you have this, then it's a spam. So that's a labeled data set. If it's unlabeled, then you just have the emails. So what do we do with that? No idea. You could maybe perform clustering. That's for unlabeled data. But yeah, this is an example of a labeled data set. Any other question? Okay, great, great. Um, I'll stop sharing. Before I end, can I make a quick um, survey? Title. I will start now. I'll share something. Wait. Share screen. Can you see it? Enjoying this title. Okay. Okay. So first question here is, after what you have learned in this session, how would you describe ML or AI in 1 to 3 words? Hmm. Still no participants. Training. What about smart automation? Mhm. Yeah. Yep. It can be complicated depending on the context. Yeah. Potentially. Mm-hmm. Potentially useful. Okay. I think. What else? What's the second question? On a scale of 1 to 5, how well do you understand the topic so far? At least like the basics of ML. What is ML at a high level? Okay, two respond. That's 4 responses. Mm-hmm. Okay, great. Next. So quite average. 3. What's the most valuable thing you learned today? No, none. Okay, that's a good day. Yep, it's really important. What else? Mm-hmm. It is the future. Yeah, agree. Mm. I'll wait for one more. Okay, latest essentials, ML, school to training. That's it. Yep. Right. Right. Great. Great responses. Thank you. Do we have another question? I think that's the last one. Ah, okay. Last one. Where do you plan to use ML or AI? PCs. So, okay. Okay. For social good. Right. Mhm. Okay, great. Thank you for that. Yep. Online tutor, content recommendation, hobbies. Great. Okay, I'll stop sharing now. Thank you. Thank you. Do
Hey
you have
Jude, thank you so much for your for joining us. I think are there any things that you would want to share, especially to those who are listening to us to know more about machine learning? Which resources that are helpful for them if they're planning to start their journey towards yeah, doing projects in machine learning?
Mhm. Um, I suggest having good foundations, like study the math, statistics, but also try to apply them whenever you can. Like, do a pet project, something that you're really fascinated in. Try to use what you have learned, even though it's just a basic project. At least you can apply what you've learned, and it will reinforce what you've learned. And the idea is maybe after that you will explore more complicated models, more sophisticated techniques, because at least now you have learned the basics. So I suggest doing lots of personal projects and have good foundations. For the resources, I suggest maybe starting with an introductory course on Coursera in machine learning. That's where I started back then. But after that, please read the books because there are so many content out there that it's hard to figure out which ones do make sense, which ones are really relevant. There are so many tutorials, there are so many articles. There are times actually when I've seen that they do not um, you know share the correct things because many articles now are not filtered very well. You could actually publish your content even though maybe the things that you are sharing are not that accurate. So that is why I still suggest that you read books because they have been read by experts. They have been validated by so many um, peer reviewers. So yeah, please do read books on ML if you have time.
Okay, all right. That's a good recommendations, Jude, to relatively learn, read books, and to also access different types of content to be able to learn more about machine learning. So thank you so much, Jude, for spending your afternoon or Saturday afternoon with us and sharing with our listeners and who are tuning with us to learn more about machine learning. And yeah, thank you so much, Jude.
Thank you. Thank you. Have a great day.
All right, so thank you so much, everyone, and we're ending our 30 days for ML. session for this Saturday, and stay tuned for our upcoming events. Follow us on AI Pilipinas, and we'll have a set of talks in the upcoming weeks. So make sure that you follow us. Thank you so much, and have a great weekend, everyone.